This is a review over quadratic functions and parabolas. It's also the test review worksheet 6-9. First off, it says the highest and lowest point on the parabola is the, you should have vertex. The U-shaped graph of a quadratic function is called a parabola. A parabola is a graph of a quadratic function. The quadratic parent function is y equals x squared, or you write it as f of x equals x squared. Graph the quadratic parent function f of x equals x squared and fill in the table of values. Well, we can always go into the calculator here, put in there y equals x squared, press second graph. And as we look here to go down to find my symmetric points and things, first off I have, it gives us the numbers we're supposed to do here. Let me see here. There we go. Kind of disappeared on me. I have -3, 9, 4, that's 1, 0, 1, 4, and 9. And if you're wondering where I got it, it was right there in the calculator. I put it into y equals, put x squared in there, press second graph. And got the table. Now I can graph it. 0, 0, 1, 1, -1, 1, 2, 4, -2, 4, 3, 9, 1, 2, 3, up 9. And I can sketch in the parabola. Okay, what is the vertex? The vertex is the point where the parabola changes direction. It's right here at 0, 0. It's also here at the table. Okay, that vertex is also going to be a minimum point because it's at the bottom. Oh, it says circle the point, the vertex in your table, which I did, and label it on the graph. So here it is, vertex. Now it says name a pair of symmetric points. Okay, well, symmetric points are where the y numbers are the same. So here's one. I've got -1, 1, -1, 1, and 1, 1. You could have chosen -2, 4, and 2, 4. You either even could have done -3, 9, and 3, 9. The axis of symmetry. Your axis of symmetry is the line where you could fold the parabola in half. In this case, it goes right, oh, nice straight line there, not so much. It is x equals whatever the x number is of this vertex. The x number is 0. So your axis of symmetry is x equals 0. Next, graph the function. It says f of x equals x squared plus 5. Well, we can go over here. I can go into the calculator, put in there x squared plus 5. There it is, plus 5. Second graph. I can look and see. First off, I see that I have, if I wanted to make a little table, might be a little easier if you need to sketch that to do that. I have -3, 14. Let's do -2, -1, 0, 1, 2, and 3. Well, -2, 9, 6. That was 5. 6, 9, and 14. If you want to double check what I saw, there it is. Okay. So now, wants us to figure out what the vertex is. The vertex is 0, 5. It's right here. So I would go up to 1, 2, 3, 4, 5, put a dot, and I have 1, 6, -1, 6, 2, 9, -2, 9, and I kind of ran out of room there, so there's my parabola. Now, which statement best describes a graph when compared to the parent function? Remember, the parent function is y equals x squared. We just did that. That started here, and I had 1, 1, -1, 1, 2, 4, -2, 4. Okay? So what happened? It says describe the graph when compared to the parent function. From the parent function, it was moved up 5 units. So the graph was shifted up 5 units. What is the axis of symmetry for that new parabola? Well, that axis of symmetry, where am I going to fold it in half? It's right here. It's x equals the x number of the vertex, which is x equals 0. What is the range of the function? First off, you need to remember that range is range x or y. Range is going to be y. Now, I start down here on the y. I start at 5, and it's all these numbers upward because it opens up. So it's going to be y is greater than or equal to 5. Now it says shift the parabola down 9 units and graph it on the graph provided. Well, let's start here at the 5, and let's go down 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my new one. And on these parabolas, you go over 1 and up 1 from the vertex. Over 1 and up 1. I can also go over 2 and up 1, 2, 3, 4. And now I can graph it. It's the same width. The only difference is the vertex is different. So right here, that vertex is 0, negative 4. So my equation is y equals x squared minus 4. Next. Which of the following functions has a parent function of y equals x squared? So which ones of these, when you put it in the calculator, which one of these down here would give you a parabola? So if you don't know by looking at it, you can't, and first let's remind ourselves, I'm trying to figure out which one is going to make a U-shaped curve. This one, if you put it in the calculator, it's going to be a horizontal line. That is not it. This is linear. If you don't believe me, go in the calculator and put in there x, whoops, let's make that one an x squared here. Let's go back over there and make sure we know linear parent function. And in y2, put in there x minus 3. Oh. And press graph. There's the parent function. X minus 3 goes right there. That's linear. That's not the right answer. Next one I have is 2x to the third. Well, let's go down here. I've got 2x to the third power. Press the caret key, the 3, plus 4. Press graph. There's the parabola. Does the next one make it? Nope, it does some funky thing. Well, I hope the last one works. So we have, let me go up here. I've got, go down here. I've got 4 x squared minus 4. And press graph. Parabola. Next parabola sure does. It still makes a curve even if it doesn't look exactly the same. Describe how the graph y equals x squared would be affected if you changed it to 5x squared. So when you have the parent function and you put a coefficient in front, and one that's bigger than 1, it's going to make it narrower. It's going to cause it to stretch. The next one, if you have y equals x squared minus 4 and it's shifted up 3 units, what is the new function? So you add 3 to that and you get y equals x squared minus 1. Next one, the graph of the function y equals x squared plus 7. If it's shifted down 4 units, subtract 4 from the constant. It's y equals x squared plus 3. When graphed, what function would appear to be 3 units up from the graph? So if it's up, you add 3 units to it. So my new function would be f of x, or y equals 2x squared minus 1. Number 12, how would the graph of the function, there's a whole lot of words going on here. Let's move this down a little bit. How would the graph of the function y equals x squared be affected if the function was changed to 2x squared? Well, what is this lead coefficient going to do? It's going to make it narrower. It's going to stretch it. It doesn't change the position. It's still in the same spot. And if you don't believe me, go in the calculator Put in there that parent function, then put in there 2x squared, and press graph. So right there it's narrower. Next one. A portion of your graph is shown at the right. At what point will the graph cross the x-axis again? Okay, well, let's kind of sketch here. We continue it, and I'm going to go up, put a point here. I'm going to follow like this is my axis of symmetry. I'm going to follow the pattern. It's going to cross here. And as I go up, let's see. I see that this is 1, 2, 1, 2. So here it is crossing again. That is at 2, 0. How did I know that? I finished the graph. Next. What is the vertex? Oops. Let's see here. There we go. What is the vertex of the function shown below? Vertex is a point where the parabola changes direction. Down here, I have 0, -6. The axis of symmetry, the line where the parabola folds in half right here. So there's my axis of symmetry right there. It's x equals the x number of the vertex, x equals 0. What is the range? I have range is y. Now the parabola opens upward, so it's all these points above this number, so it's greater than or equal to -6. The function for this parabola, y equals x squared minus 6. Next, number 15, it says compare the graphs y equals 3x squared and -3x squared. Describe how the graphs are alike and how they are different. Use at least 4 of the words or the phrases in your description. So I can go in here and let's put in there, let's see, let's make this one 3x squared. Let's go down here and make this -3x squared and press graph. Well, how are they the same? Both of them, if I look at these words here, both of them are parabolas because they are parabolas. And one thing that's the same right here, the axis of symmetry is the same because they can be folded on the y-axis where x equals 0. And the AOS, axis of symmetry, is the same. There's one more big key fact that's the same. If you look here, they both have a coefficient of 3. Don't worry about the negative, it's just the number. So the widths are the same. Now, what's not the same? Well, this one opens downward and one opens up. So the direction is not the same. And another good thing to point out is that the -3x is a reflection over the x-axis. And -3x squared is a reflection over the x-axis. Another thing that you could say was the same would be your x and y intercepts. They were both at 0, 0. Next, which set of ordered pairs satisfies the function? So what I would do, first thing, go in the calculator here. Let's go down, erase that out of there. Let's go up and put x squared minus 2x minus 2 and press second graph. And let's match our tables. It says, let's start with -1 here. I've got -1, 1. Well, it's not -1, 0. Or -1, -1, 0. Let's see, I've got -1, or I've got 1, -3 on both of them. What about 3? This one says 3, 1. So it matches with D. Next, the graphs of two functions are shown below. Write the equations of the two parabolas. It says, hint, the coefficients are 1. So y1, if the coefficients are 1, I'm going to start off with x squared. And then I'm going to look at the vertex. The vertex is +1, so I have x squared plus 1. y2, again, the coefficient is 1, so I start off with x squared. 1, 2, 3, 4, 5. That's at -5, so it's -5. Number 17. Okay, gives us all the equations that go with each one of these. It says, what is the vertex of y3? So let's look in y3. I've got 54, 54, 24, 24, 6, 6. Okay, this one is not 0, and then the x number of 0. The vertex is 0, 0. Now it says, what is the symmetric point to 224 in y3? So I have 224. Match it up with the 24. I've got -2, 24. What is the axis of symmetry of the parabola y3? Well, axis of symmetry is x equals whatever the x number is of the vertex. So x equals 0. What is the vertex of y2? 14, 14, 9, 9, 6, 6. I've got 5, and there's my x, so I've got 0, 5. My axis of symmetry, x equals the x number of the vertex, x equals 0. Symmetric point to -1, 6. -1, 6 goes right down here with 1, 6. It says compare the points of y1 and y2. Which of the following are true? Okay, look at y1 and y2. What's the difference between these? So I'm looking in these two, these two columns right here. Okay, so let me see here. All right, there we go. Well, I go from 0 up to 5. 1 plus 5 is 6. 4 plus 5. So this must be shifted. It's going up 5 units. So y2 is shifted 5 units below y1. No, it's not wider an arrow. It's right here. It is shifted below. Y2 is shifted. Y2 is shifted 5 units above y1. Yes, it's going above by 5. Next one. A book was dropped under a motion detector. The following data was collected. Which of the following best represents the relationship between the distance from the motion detector and the time elapsed? Well, the easiest thing to do on this one is to not pull that up. Let's see here. All right. Let's go here. And let me move this over just a little bit. Well, one thing I'd look at is I've got, you can put these all in the calculator and figure them out, but let's look here. This says 0 and 1.38. So I know my last number has to be positive. See, because right here it says -138. It's not going to be that one. That says plus. That says plus. That one has some kind of B. I've never seen that. So let's look at these two down here. So that was just me trying to eliminate some things here. I'm going to go 16. Let's see, 16x plus 1.38. And I'm going to press, oh, not graph. I didn't mean to do that. Let's go second graph. Okay. Now, the problem is these go by 0.1s. So we need to go to second window. Table start, let's start at 0. And let's go down here and put in there 0.1. So now let's go second graph. I have 0.1 and 2.98. Nope, that's not what that is. So what happens if I change this over here to x squared? Whoop. Oh my goodness, my calculator is second insert, put in there the squared. And I have second graph. Now look at the table. Sure enough, now my y1s all match up. So my answer should be D. Next, on this one, it says a ball was hit and had an initial upward velocity of 96 feet per second. The function that describes the position of the ball at any time after it was hit is h equals 96t minus 16t squared, where t is the time in seconds and h is the height in feet. The graph of this function is shown below. What is the maximum height of the ball? It says the maximum height of the ball was about, well, maximum, let's go to the top of the parabola. Let's see if I can get my pen to work here. Is right here. It looks like it's in between 140 and 150. I'd say it's about 142, anywhere close to 140. It has to be above 140, but less than 150. The ball was in the air for blank seconds. So it started here, it went up, and it came back down. It was 6 seconds. The ball was at the height of 80 feet at, so you go up here to 80, right here, and here. So you have 1 second and 5 seconds. The next one, it says using the graph at the right, answer the following questions. First off, what is the minimum point? The minimum point down here at the bottom is right here, which is 2, -1. Right there. What is the y-intercept? The y-intercept right here is right here, this point, which is 0, 3. The x-intercepts are here and here, so that is 1, 0 and 3, 0. Give 2 pairs of symmetric points. Okay, symmetric points right here, they have to have the same y values. So you can use 1, 0 and 3, 0. Those work. They have the same y numbers. The other one, let's see, I've got 0, 3. And then its symmetric point right here is 4, 3. See if we can find another one. Right here, I have -1, 8. And I go over here, and it is 5, 8. Now my symmetric, my axis of symmetry is x equals whatever the x number is of the vertex. There's the vertex right here. See the line where the parabola is folded in half is right here. That is x equals 2. Now it says for what values of x does the function equal 8? For what values of x does the function equal 8? So I'll go up here to 8, and right there we already found it's -1 and 5. So it's when x is equal to -1 and x equals 5. That's what we found right here in those symmetric points. Next ones. What is the maximum point? Here's the maximum point up at the top. It is -2, 5. The y-intercept crosses right here. You should have 0, 1. Give 2 pairs of symmetric points. Well, let's try that right here. I've got 0, 1, and the other symmetric point is -4, 1. Another one, if I cross down here, is 1, -4, and -5, -4. Now the axis of symmetry, that's the line where you can fold the parabola in half. Right here, that right there is x equals 0. For what values of x does the function equal -4? Well, we already found, let's see, where the y is -4, that's right here. And it is x equals -5 and x equals 1. The next one's, how do you know if they're linear, quadratic, or neither? Well, first off, if they're linear, delta y over delta x are the same. Now remember, we talked about if they're quadratic, you had to do the delta y's had to be the same. So if I start here, I have minus 6, minus 12, minus 9, that's delta y, delta x, plus 2, plus 4, plus 3. Negative 6 over 2 is negative 3. Negative 12 over 4 is negative 3. Negative 9 over 3 is negative 3. Since they are all the same, this is linear. Let's look at the next one. Delta y. This is plus 28, plus 20, plus 12. Delta x, plus 1, plus 1, plus 1. Now delta x, try delta y again, because see now I've got 28 over 1, 28, 20 over 1 is 20. That doesn't work. So let's see if the deltas work. This is minus 8. This is minus 8. Okay, so since the next deltas right here, these work, this is quadratic. Next one, plus 14, plus 2, plus 2. Delta x, plus 1, plus 1, plus 1. Delta y over delta x, 4 over 1 is 4. 2 over 1 is 2. Well, it's not linear. And if you do the deltas again, this is minus 2 and this is plus 0. That doesn't work, so this is neither.